All right, here, y'all. This is going to be a little different because I'm using a PowerPoint. I'm not used to using PowerPoint. Here we go, slideshow. Okay, so hopefully this is going to show up well with the being a PowerPoint. I'm having to adjust stuff instead of going off to how to show you how to calculate pH, which is math. I'm just going to go back over how to name and then also write formulas for acids and bases, because I know a lot of you were still stuck, and I also know that a few people were just looking up on the internet how to do stuff, and yeah, you didn't figure out how to actually do the nomenclature. So I haven't popped this opener in, which is how I'm going to be taking attendance yet. And I know it says focus and it says OBJ instead of SWB, but that's just the way that I used to do it at my previous district. So for the opener, and I know it says focus, it says, what is the difference between an acid and a base? And the thing that makes an acid is that it's going to start with hydrogen. Okay, it's that hydrogen that's given off into the solution, technically in the form of a hydronium, even though I didn't tell you guys that word. It's that increase in the hydrogen concentration, which is going to make it either a stronger or a weaker acid. And then for a base, bases normally do have hydrogen in them, but it's in the form of what is called hydroxide, which is capital O, capital H, and it does carry a -1 charge. The hydrogen is just capital H and it carries a +1. Now, there are one major exception for a base, and that is the ammonium, which is NH3, which is a very strong base. But most bases are going to have that OH at the back. Now, I do have a secondary paper. I will leave this out in paper. I will leave out polyatomic ion. No, yes, polyatomic ion chart is on the opposite side of the paper for today. If I say tomorrow, I mean today, because I'm doing this on Monday, and you guys are going to see this on Tuesday. But you're also going to need a periodic table for the charges. Now, I know this is done up as notes, but you guys aren't taking notes. This is just going back over this the way that I was taught how to do it, which the way that I showed you guys last week is totally valid. It's just that's not the way that I was taught. So if you need to write this down, I'm not going to check for this when I check your notebooks, but for those of you that have to write this stuff down, you're more than welcome to. I only have about 15 minutes to try to record this because I have to help my daughter with her asynchronous stuff. So if I go a little too fast, by all means, just pause it, and you can go back and take a look at it. Okay, so there's technically 4, okay, but there are 3 major types of acids, okay? The way that I was taught how to do this, both when I was your age and all the years that I have taught chemistry, is the way you tell which of the 3 major types of acids, which one they are, is you look at the thing that is not the hydrogen in the front, okay? So it might just be one element like nitrogen, okay? It could be a polyatomic ion like nitrite or nitrate, and most polyatomics end in either ite or ate. Now, there's a major exception, that's the ammonium ion, and that's cyanide, but most of them it's ite. Some have hypos and some have pers in the front, but the ending is either ite or ate. So the other major type of acid is going to be a regular element, which will end in I. Okay, so once again, but this is different, because these are my notes that I've done for forever and ever and ever. These aren't Aisl's. So we're going to be taking a look at the ending, okay, of the anion, not the hydrogen, which is a cation because it's +1. So this is what we're going to focus on today. The first one I'm going to tell you are the ide anions. Okay, so these are going to be elements, with the exception of cyanide. Okay, it's a hydrogen and then one other thing. You're not going to see extra oxygens back here. Okay, so no oxygens are the ides. So this is being named for the nitride ion because that's from nitrogen, it's nitride. And this one's going to be named for the sulfide ion that comes from sulfur. I can't remember if there's one more on here, so I might be going forward and back. Okay, there isn't. So if it's hydrogen and one other thing, these are ides. And they have a very specific naming set. They don't do the same stuff that the ites and the eights do. The ites and the eights have a couple things in common. Primarily, they have oxygen, they're polyatomic. Or in the notes that I showed you, they were calling them tertiary acids because there's 3 or more different elements that are in there. These are binary. These are two elements. And I don't care if there's a 3 behind that hydrogen or 2. It's hydrogen and nitrogen. It's hydrogen and sulfur. So if you have an ide, you're going to, most of the time, just replace it with ic. So nitride would be nitric. Now there's a couple of weird ones in that sulfur and phosphorus. Can't remember if I go over that or not, but if I don't, I'll come back and explain it. It's just, I can't write on the screen. I'm at home right now. Not that I can write on my smartboard, but I'm just trying to talk you through this. So if you have an ide, no oxygen, replace it with ic. It's at the end. And then you're going to put the prefix hydro in front of your root word. Your root word is your non-hydrogen thing. And then you can't forget to put the word acid. Okay, so in this case, and I'm going to walk through this as slowly as possible, it's named from the nitride ion. Ide is going to become ic, okay? And it does carry a -3 charge. It's from the the periodic table. So this was the first step. Replace ide with ic. I just put the charge up here because we're going to have to be able to go both from names to formulas and from formulas to names. So then the second thing is I'm going to put hydro in the front. And then the last thing I have to do is I'm literally just going to add the word acid. And this is, I've heard it pronounced both hydronitric and hydronitric. I've heard it both ways. It's just sort of like, not that I've ever heard somebody call a potato a potato, but it's that concept. And these may very well be on the assignment from today. Okay, so once again, an ide does not have oxygen in it. Replace ide with ic. Put hydro on the front, add acid at the back. There are no hyphens. In case I don't have the example, the one that doesn't just immediately switch, sulfide would become sulfuric, so hydrosulfuric acid. And then the other one that's just a little weird, phosphide, is from phosphorus. So that would be hydrophosphoric acid, not hydrophosphic. So it's not sulfic, it's sulfuric. It's not phosphic, it's phosphoric. They're the only 2 that you need to go back to more of the original element's name. Now, the ones that do have oxygens, these are your ites and your eights. They're only polyatomics that do not end with ite and ate are cyanide, hydroxide, and ammonia. And hydroxide is not an acid, so we can ignore that. Ammonium becomes ammonia, so we're going to ignore that. So really the only one on the polyatomic ion chart that's going to follow the previous rule is the cyanide ion. So that would be hydrocyanic acid would be that one. That's the capital C, capital N. And so anyways, back to these. When you take a look at it, both of these ions, these are the phosphorus tertiaries. Ite does not mean 3 oxygens. It doesn't mean 2. It doesn't mean 1. It means 1 less. 8 means 1 more. Doesn't mean 4. Doesn't mean 3. So if you take a look at these side by side, the one on the left is the phosphite ion. The one on the right is the phosphate ion. Now, you obviously would have hydrogens in front of these. They're an acid. But I'm focusing on these anions and their suffixes. to figure out what's going to happen. So if it was nitrite, it would be NO2 with a -1. If it was nitrate, it would be NO3 with a -1. So like I said, this number does not mean either 8. It's just more or less. Oops, that's not animated right. Oh, well, I'm not going to have time to do this twice. When you have an 8, okay, this is fewer, okay, or just look on the polyatomic ion chart, put it on the other side of the assignment. Change ite to us. There are no prefixes, but you do need to include acid behind your anion that you've changed. Okay, so this is going to be the example that I'm going to use. I've got my acid component. When I look up NO2, because I don't have the other one next to it, this is the nitrite ion. It carries a -1 charge. So step 1, I'm going to replace ite with us, and I do not give it a prefix. All I have to do is put the word acid on it. So if this was the sulfite ion, SO3 with a -2, that would be sulfurous acid. If this was the phosphite, this would be phosphorus acid. So ite is changed to us. Do not give it a prefix. Don't forget the word acid. You have an 8. That's not animated either. I apologize. If you have an 8, okay, this is the one that has more. You know both, or you can just look it up. You're going to replace 8 with ic. No prefix again. You cannot forget the word acid. Now, this is the other polyatomic with nitrogen in it. NO3 is the nitrate ion. I am going to replace 8 with ic. So that would be nitric or nitric. I really don't care. There's no hydro, and then you just don't forget the word acid. You don't have any exceptions to the rule with this way. The way that I showed you from before, because I like to stay with the other chemistry teachers, had all those exceptions. So if you have something like HClO with a -1, and you look that up on your polyatomic ion chart, that is hypochlorite. So you don't change the prefix. So if it's an ite, it becomes us. So that would be hypochlorous acid. Like, it's already part of its name. So there is no, if there's 1 oxygen, it's this. If it's 2 oxygens, it's this. There's no exceptions with this way. Is it an ite, or an 8? That's it. And you do not change. If it does have a prefix like hypochlorite and perchlorate, then you leave it alone. And if for some gosh darn reason on the CVA, they do have one of the weird ones that is not on the polyatomic ion chart, I will tell you the name of the anion. And you still need to know the rules. Okay, but I'm not going to make you memorize that entire polyatomic ion chart at this point. You need to know how to use everything. So this is what I tried to do on the board, is if it's an 8, I ate it, it's icky. So 8 becomes ick. And then the other thing, apparently you guys still say I for all right, but I thought this was something from the 90s. Apparently it's still a thing. So the ite becomes us. And it's all right with us, or it's I with us, which was that is what that's supposed to mean. Sort of embarrassed that my generation did that, but hey. And then I don't have a silly way to do the ides. It's hydrorootic if it's an ide. I wish I had a silly little way to keep it straight, but I don't. I've had students try to make some inappropriate analogies with this, and I can't do that. It's just not kosher. I can't do that. So we're going to do one of all 3. And I left off the hypochlorite and the perchlorate because the chlorine acid's actually a 5. but we're going to do the three main rules. HCl is from the chloride ion, HClO2 is from the chlorite ion, and the HClO3 is from the chlorate ion. If you don't believe me, you can go look them up on your polyatomic ion chart, because I'm not lying to you. Ide and ate becomes ick. Ite becomes OUS, us, not like US, OUS. All of them are going to get acid. The only one that's going to get a prefix is the ide. So chloride becomes chloric, chlorite becomes chloros, chlorate becomes chloric. The only one that gets almost said a root word. The only one that gets a prefix is going to be this one, because it's the ide. And then they all are going to end with acid. I didn't have room to put acid over here. Sorry, I just wouldn't have. Oh, no, I did it down here. Hydrochloric acid. I don't think I have another one on there. I don't. Okay, so you guys have the period. If you need to go back, I'm not going to look for this. When I check your stuff, I'm really hoping that this went through properly. Turn off my presentation. Like I said, I've got polyatomic ion charts on the other side of the assignment. Make sure that you do answer the opener that's on taking attendance. This paper is an assignment, and then I'm going to be teaching you guys how to do the math with pH. We're going to be a day behind. I should be back Wednesday, no problem. I just know I'm not going to be emotionally prepared to be able to come to school tomorrow with everything that I'm about to have to do this afternoon. So if you have other questions, please don't send me emails today. Please. I need to just sort of take care of what I have to. But if you do have questions, I will address those on Wednesday. Stop.